Let us study extraction of reactive metals. Here there are few examples of reactive metals. They are lithium, sodium, potassium, aluminium, calcium, magnesium, etc. Like that way there are different metals. These metals are reactive metals. Now, how do we understand they are reactive metals? Because these metals are having the capacity to remove or lose their outermost electrons easily. Because of that, we can say that they are electropositive elements. Their outermost electrons they can easily remove out. So, we can say that they can be able to form cations easily. Cations, its meaning they can form positive ions easily. Because of that, we are calling them as reactive metals. Again, we already studied about highly reactive metals. Example, we can say potassium, then sodium, then lithium, we can say that even magnesium, then calcium. All these elements we can say that they are highly reactive elements. So there are reactive elements, even there are highly reactive elements. Highly reactive elements speciality, even if we are keeping them in open at the room temperature, they catches fire. That means they react with the oxygen. So now these elements, we can say that these reactive elements as well as highly reactive elements in that sodium, potassium, such elements are there here now. Now how we can be able to extract them? For extracting, that means separating pure metal from their compounds. Especially we can say that from their chloride compounds we can see. From their chloride compounds we can be able to extract these metals. That means we can be able to purify. Now suppose chloride compounds of lithium chloride, sodium chloride, potassium chloride, like that way chloride compounds. From that we can be able to separate these metals alone by using a separate method or a specific method. That method is known as electrolytic reduction. Electrolytic reduction. This electrolytic reduction has got one more name, that is electrolysis. Now we will study what is electrolysis in a deep way. I am using one container here, a beaker we can say. In that 2 electrodes I kept. And now I am doing the extraction or we can say purification of sodium from sodium chloride, potassium from potassium chloride, calcium from calcium chloride, aluminium from aluminium chloride. Like that way I am taking now here sodium chloride. Its solution I am taking here. We can say that here now I taken sodium chloride solution. We can say that this sodium chloride solution is acting like an electrolyte here. This is an electrolyte. Why it is an electrolyte? Through this solution electricity can be able to flow. Now here I taken 2 electrodes. Now these 2 electrodes I am connecting with positive as well as negative terminal of the cell. Then here I am connecting one bulb and here one key. This is positive terminal, this is the negative terminal. Now here, as and when we pass current through this, we can say that here now positive terminal is there. So this is now here negative terminal. So we can say that a circuit is completing now. Now we are passing current. That means we are switching on here. We can say that here now plug key kept it, just we have to insert. So switch on. We can think now we are putting on this circuit. As a result of it, from positive terminal to the negative terminal, current flow will take place through this electrolyte. Here sodium chloride electrolyte, sodium chloride solution we have taken. So we can say that once we people are making sodium chloride solution, in this solution there will be sodium ion as well as chloride ion. So we can say that in this solution there will be the movement. They won't remain in one place, they can move in this particular solution. So we can, now we people are flowing current through this solution. So as a result of this, here we can say that this sodium chloride solution, we can say as it is the aqueous solution, liquid solution. In that, number of sodium chloride, sodium ion as well as chloride ions will be there. Now here we can say that the electrode which is connected to the positive terminal of the cell, this is known as cathode. Sorry, positive terminal, that is known as anode. Here positive, this electrode also having positive sign, so we can say that this is anode. Positive terminal of the cell connected to the anode, that is positively charged electrode. Here we can say that this is the negative charged terminal that is connecting to the negative charged electrode. So we can say that this is known as cathode. Cathode is the electrode which is having negative charge. Its meaning here full of electrons are present. Here full of negative charged particles are present. Here full of positive charged particles are present. Now, as and when we flow current through these electrodes, we can say that here now minus charge is there, cathode is there. So here all metallic particles will come. That means where cathode is there, there full of sodium will come and collect. Here full of sodium ions will come and collect. Here now positive charge is there. Here all negative charged particles, that means the Cl minus will come and collect. So where negative charged electrode, where positive charged electrode is there negative charged ions will come. Where negative charged electrode is there positive charged ions will come. We can say that here now all positive charged ions came, Na plus, Na plus. Now, how metals are becoming positive charged ions? Here I am saying you now, sodium atom. This is sodium atom transforms to sodium ion. How it is transferring or transforming one sodium atom, how it is changing to sodium ion. So sodium atom transforms to sodium ion by losing electrons. By losing electrons, sodium atom transforms to sodium ion. Now chlorine atom transforms to chloride ion by gaining electrons. We can say that here by gaining electrons. Sodium atom transforms to sodium ion by losing electrons. At the same time, chlorine atom transforms to chloride ion by gaining electrons. So here now, this place full of sodium ions are there. As and when these sodium ions they are having less number of electrons now. Sodium ions having less number of electrons. Why? Because they already lost their outermost electron. Now, as and when they reach here they can find that abundant number of electrons in this electrode. Negative charged electrode is there. So that means full of electrons are present in this electrode. As and when this sodium ion or metallic ion reaches to the cathode, from there these sodium ions will receive electron. Sodium ion, that is Na plus ion, already reaches to air, reaches to the cathode. As and when it reaches here, immediately it receives electrons from this cathode. As a result of it, we can say that it receives electron. This is cathode reaction I am saying. Cathode reaction. Cathode reaction means on this cathode what is happening. So here as a result of electrolysis process, sodium ions will go towards the cathode. Then from there, how much electron it is lost? Each one lost one electron. Here we had already studied. Sodium lost one electron, as a result of it Na plus ion became. So here now one electron, all these sodium ions or sodium atoms lost one electron, as a result of it sodium ion became. So the lost electron they will gain from this cathode. As a result of it we can say that sodium ion, once it reaches to the cathode, from there it receives one electron. As a result of it, here sodium atom formation will take place. So here we can say that sodium ion, once it reaches to the cathode, from there it accepts electron. As a result of it, again sodium ion changes to sodium atom and it will collect in, or it will collect on the, or we can say it will deposit on the cathode. So sodium ion reaches to the cathode. After that they receive electrons from the cathode. As a result of it, it will become, or on this cathode, full of, we can say that sodium atom in deposit condition. So here first here sodium ions will rush to the cathode. After that from there they receive electron. Then later here or on this cathode there will be the deposit of sodium atom. So we can say that sodium ion reaching here, afterwards it transforms, it changes to sodium atom by receiving electrons from cathode. So that reaction I shown here. At cathode, which reaction is taking place? Now we will study about anode. At anode now what reaction will take place? Anode means positive charged particles are present on this electrode. Towards there chloride ions rushed, Cl minus ions rushed. Once they reach here, so Cl minus ions specialty what is there? This chlorine atom or these number of chlorine atoms, they receive electrons from sodium atoms. As a result of it, they are becoming chloride ions. Chloride ions speciality, they are having number of electrons more. Chloride ions speciality, here you see, here chlorine atom, this changes to chloride ion by gaining electrons. So we can say that one chlorine atom changes to one chloride ion. Similarly here, number of chlorine atoms changes to chloride ions as a result of the reaction between sodium as well as chlorine. So here I am writing in a chemical reaction form, but it is not the correct reaction, just as a symbol like I am showing you. Cl never remains single, but even then I am showing here. So now need of balancing and showing you at present. Because of that here Cl single I shown, but never remain chlorine single, but just for showing you as a simple condition I am showing you now. So here sodium reacts with chlorine, as a result of it sodium chloride is forming. Sodium, its electronic configuration 281, chlorine, its electronic configuration 287. So from this sodium, one electron receiving by chlorine. As a result of it here sodium chloride is forming Na plus NCl minus ion. Sodium, its sodium ion electronic configuration now 28 became, chlorine, its electronic configuration 288 became. Now what is happening? As and when this chloride ion reaches to the anode, here the problem of positive ions are present. Here we can say that positive charged particles are present on the anode. That means here deficiency of electrons on this electrode. As a result of it, when these chloride ions reaches, chloride ions are having extra electrons. At the same time on this rod deficiency of electrons. So as and when chloride ion reaches here, they gives away or they give away their extra electron to the anode. So here now Cl minus ion goes to anode. As and when it reaches at the anode, the extra electron which is there, that it gives to the anode. So here Cl minus ion already reached here, but the problem they are finding that here full of positive charged particles only, no negative charged particles. So positive charged particles, its sign is they are having lack of, absence of electrons. So as and when this chloride ion reach, they give their extra electrons to this anode. As a result of it, these chloride ions lose their electrons and they become chlorine atom. So here now chloride ion, Cl minus ion reached, but here there is lack of or absence of electrons. As a result of it, this extra electron giving to this anode. So here now minus sign which is there, minus sign they are having, that thing giving to the anode. As a result of it, these chloride ions transforms to chlorine atom. Then on cathode as well as anode, in which form these as and when ions reach, but in the form of ions they cannot collect here. The deposition of sodium as well as chlorine is taking place in the form of atom, not the form of ions. Ions will reach here, but ions transforms to atom, and in the form of atom they collect on cathode as well as on anode. Now at the anode, which reaction is taking place, that we will see. Here now we can say that chlorine, one chlorine is having minus sign, that means it is having chloride ion already reached here. So that is having one electron extra. This electron got from sodium, that we had already studied here. Now this thing transforms to chlorine atom by giving extra electrons. Here now, this is not correct now, I will balance it and show you. Chloride ion transforms to chlorine atom on or at the anode. When it is reaching there, what is happening, that only I am showing you. Chloride ion transforms to chlorine atom. But problem, a single chlorine never remains. It cannot exist single. It will always remain in the form of double. That's the reason I written here Cl2. If here Cl2 will be there, here we have to write 2Cl minus. If 2Cl minus means 2 electrons are there, so we have to show here 2 electrons. Electrons charge is negative. So here we can say that 2Cl minus transforms to Cl2. That means in the molecule form. Again here how this is forming after adding. This chlorine is becoming after adding electrons with the after removing electrons from the chloride ion. So these electrons are removed. As a result of it, here adding work is happened. Now I am saying you, this sodium added, reacted sodium ion absorbed or reacted or received 1 electron. So here electron receiving took place. So we can say that this is an example of reduction reaction. Sodium ion received 1 electron. So we can say that this is an example of reduction reaction. At the same time, this chloride ion, once it reached at the anode, it removed its excess electron. So we can say that when the removal of electron is taking place, then we can say that that is an example of oxidation reaction. So here sodium ion received 1 electron. Here received electron. So we can say reduction reaction. Here chloride ion removed electron. So we can say that that is an example of reduction reaction. Now we will study extraction of moderately reactive metals. Here now, which are moderately reactive metals, that we will see. Here now, iron, zinc, copper as well as lead. Iron, then copper, zinc as well as lead. These metals we can say as moderately reactive metals. Iron, copper, zinc, lead. These metals are moderately reactive metals. Their speciality, these metals are available in the form of sulfide as well as carbonate compound. So we can say that these metals are available in the form of sulfide as well as carbonate compounds. Now, for separating from sulfide as well as carbonate compounds, these metals separation we have to do now. Now, directly removing from sulfide as well as carbonate compounds, it is a bit difficult. So, what we have to do? First, we have to convert this sulfide or iron sulfide, copper sulfide, zinc sulfide, lead sulfide, or we can say iron carbonate, copper carbonate, zinc carbonate, lead carbonate. Now, from these compounds, we have to convert them into oxide form. So, we can say that now sulfide or as well as carbonate form, we are getting it from the earth. After that, from these carbonate or sulfide compounds, removal or separation of these metals bit difficult. So, for removing them or for separating metals from their compounds easily, what we have to do? We have to convert this sulfide as well as carbonate ore or carbonate compound into oxide compound. For that, what we have to do? That we will study. First, we are doing with the help of zinc. So we can say that here now zinc sulfide as well as zinc carbonate, zinc sulfide compound as well as zinc carbonate compound we have taken. Now this zinc sulfide compound, we have to heat it in abundant quantities of or excess quantities of oxygen we have to say. That means in a large container, open container we can say. In that we have to put zinc sulfide, then we have to heat it. So we can say that large quantities of oxygen will be available. If there is large quantities of oxygen, this zinc sulfide will react with oxygen. As a result of it, we can say that zinc separation will take place, zinc oxide will form as well as sulfur will separate. So here now zinc sulfide with excess of oxygen, we have to heat it. As a result of it, from zinc sulfide, zinc oxide will form. Along with that, sulfur will produce. Now, when zinc carbonate, we heat it with limited supply of oxygen. That means we can say that the mouth of the container should be very narrow. Such a container we have to put zinc carbonate, then we have to heat it. As a result of it, we will get zinc oxide as well as carbon dioxide. So here we can say that zinc sulfide, when it is heating in oxygen, excess of oxygen, zinc oxide plus sulfur dioxide will form. Not sulfur alone, sulfur dioxide will form. Here zinc carbonate with limited supply of oxygen, when we heat it, zinc oxide plus carbon dioxide will form. Now, here we can say that when we heat it, we can say that we are roasting it. We are not adding anything. We just heat the zinc sulfide with excess of oxygen. That particular time zinc oxide as well as sulfur dioxide is forming. So we can say that this reaction is roasting. When zinc sulfide heat in the presence of excess of oxygen, zinc sulfide transforms to zinc oxide as well as sulfur dioxide. This reaction we are calling as roasting. Now, carbonate compound of any of these metals, here we people are taking only one compound, that is with zinc. So zinc carbonate. Now with a limited supply of oxygen, we are heating it. Here also we are heating it. Here also we are heating. But here excess supply of oxygen, because of that here oxygen shown. Here limited supply of oxygen, because of that here extra oxygen not shown. As a result of it, we can say that here breaking process is taking. As a result of it, zinc oxide as well as carbon dioxide is forming. This reaction is calcination process. Calcination. Here also heating process, above also heating process, but here excess supply of oxygen is there, then it is known as roasting. Here limited supply of oxygen is there, then it is known as calcination. Now, both the places we have got zinc oxide. Now, this zinc oxide we have to reduce with the help of a reducing agent, or we can say as reductant. Reductant, or we can say as reducing agent. Reductant or reducing agent. So we can say that zinc oxide, that is reacting with a reducing agent. That reducing agent is carbon. This reducing agent, or we can call it as reductant. As a result of it, zinc separates from zinc oxide and there will be the formation of carbon monoxide, CO, carbon monoxide. Now, here we can say that we have taken here carbon as a reductant or reducing agent. There are some other reducing agents are there. They are, we can say that they are carbon, sodium, aluminium, even we can say that calcium. So these all, here we have taken in this case carbon as a reducing agent. There are some other metals also acting as a reducing agent. They are sodium, aluminium, calcium. So these all elements we can say as reductants or we can say as reducing agents. We can call them as reducing agents. Now, here, these reducing agents speciality what is there? These reducing agents react with such oxides. After that, these reducing agents speciality, sodium, aluminium as well as calcium, we can say that they are reactive elements. Reactive elements, and we can say as they are more reactive than these elements. As a result of it, we can say that these elements displace. Now, which metal we are using here? That metal from there, then displacing means separating metal from this compound, then the oxygen will react with them. As a result of it, their oxides are forming. Here you see carbon is a reducing agent. What carbon done? It removed oxygen from zinc. As a result of it, carbon monoxide is formed. Now we can say that here we are using other oxides. One is manganese. Mn means a manganese. Then oxygen is there, manganese oxide. Here we can say that Fe2O3, ferric oxide. Iron available in, or iron has two valencies. One is ferrous, other one is ferric. Ferrous has two valency, ferric has three valency. So ferric its a valency here, oxygen its a valency here. Now these oxides react with aluminium. So we can say that in this case aluminium is acting like a reducing agent. As a result of it, we can say that this aluminium displaces manganese. This aluminium displaces iron. As a result of it, we will get aluminium oxide Al2O3. Aluminium its valency 3, oxygen its valency 2. Then manganese separates. Here aluminium reacts with iron oxide. So we will get aluminium oxide, then iron separates. So here now we can say that this reaction is a special reaction. When aluminium reacts with iron oxide, when we heat them, we can say that as a result of it, aluminium oxide and iron separates. This reaction is known as Thermite reaction. Thermite reaction. It is an example of, we can say that, redox reaction. Why? Because in this reaction we can say that oxidation as well as reduction takes place. Aluminium transforms to aluminium oxide, ferric oxide transforms to iron. So from this oxygen removes. So we can say that this is an example of a reduction reaction. Aluminium reacts with oxygen, aluminium oxide is forming. This is an example of oxidation. So in a chemical reaction, oxidation as well as reduction takes place. Then we can say that this is an example of even a redox reaction. Here if we see manganese dioxide as well as aluminium. Manganese dioxide transforms to manganese. Oxygen removed. So we can say this is an example of reduction. Oxygen removed, oxygen gone away. So we can say that this is an example of reduction. Aluminium reacted with oxygen. As a result of it, aluminium oxide formed. So we can say that is an example of oxidation reaction. But here now we are studying about only one reaction, that is reduction reaction, that is from manganese oxide oxygen removing with the help of a reducing agent, that is aluminium. As a result of it, manganese separates. Here we can say that iron oxide reacts with aluminium. As a result of it, aluminium, in this reaction we can say that aluminium acts like a reducing agent. As a result of it, iron oxide changes to iron and aluminium transforms to aluminium oxide. Now again we can say that here for doing this process as well as this process, we have to supply more heat energy. As a result of it, we can say that burning process will take place. Igniting process of manganese dioxide as well as aluminium will take place. Burning process we can say. When we supply heat to these two reactants, we can say that this side one's all reactants. So when we supply heat to these two reactants, that is manganese dioxide as well as aluminium, they will be in the powder form. Then we people are supplying heat to them. As a result of it, we can say that burning process will take place. Why? Because we are supplying high heat to them. As a result of it, aluminium oxide as well as manganese is forming. Here we can say that again in this case also we have to supply more and more heat. As a result of it, aluminium react with iron oxide, or we can say ferric oxide. As a result of it, aluminium oxide as well as iron is producing. From ferric oxide, when it reacts with aluminium, as and when we supply heat, aluminium oxide as well as iron forming. This reaction we can call as Thermite reaction. Now our duty to balance the equation, whether it is in balanced condition or not, that we will see. Zinc sulfide reacts with oxygen, zinc oxide as well as sulfur dioxide is forming. Let us see now. Zinc oxide, here Zn1, here also Zn1, sulfur 1, sulfur here also 1, but oxygen here, in this case oxygen 2 are there, at the same time here oxygen is 3 are there, this side 3 oxygen is there. So we will put here now 2. Why? Because here single is there, so I made it double. Now here 2 and 2, 4 oxygen became, so I am putting here now 2. Now 4 oxygen, here also 4 oxygen. So now zinc 2 here only 1 is there, so I put here now 2. Now at the same time here sulfur became 2. Here sulfur only 1 is there, so I am putting here now 2 sulfur. So as a result of it, here now 2 sulfur, here also 2 sulfur, 2 zinc, 2 zinc. But oxygen's number here 2, 2 again, 2 2s are 4. 4 plus 2, 6 oxygen became. So now I am making here also 6. 2 already there, here 3. 3 2s are 6. Then equation balanced. So 2 zinc sulfide reacts with 3 molecules of oxygen. 2 zinc oxide as well as 2 sulfur dioxide is forming. 2 Zn, here also 2 Zn, 2S, here also 2S. Now oxygen 3 O2, that means 3 2s are 6. Here now 2 and 2 2s are 4. 4 plus 2, 6. Equation balanced. Now here already it is in balanced condition. Zn1, here also 1. Carbon here 1, carbon here 1. Oxygen 3, here also 3. So we can say that this is the example of calcination reaction, even it is a balanced equation. Now let us see here. This is again balanced one. Zn1, here also Zn1. O1, here also O1, C1, C1. So equation balanced. Now here we'll see. MnO2, manganese dioxide, reacts with aluminium. So aluminium oxide is forming. So here Mn1, here also Mn1. Oxygen here 2, here but oxygen 3 is there. So we will put here now 2. So as a result of it, 2 2s are 4 aluminium. So I am putting here now 4 Al. And now oxygen 2 3s are 6. 2 3s are 6 oxygen. So I am writing here now 3. So we will get 3 2s are 6 oxygen. Problem here manganese now 3. So I am putting here now 3 Mn. So that means 3 manganese. Now once again we will see 3 Mn. Here also 3 Mn. 3 2s are 6 oxygen. 6 oxygen. 4 Al. 4 Al. Equation balanced. Now let us see here. Fe2. 2. Here only 1 is there. So I am putting left hand side 2. After that O3. Here also O3. Al here 1. Al 2 is there. So I am putting here now 2. Equation balanced. So Fe2. Fe2. O3. O3. 2 Al. Al2. So equation balanced. Now we will study extraction of less reactive metals. Less reactive metals examples we had studied already, reactivity series. They are gold, silver as well as platinum. Actually these metals are available freely in the nature. So as a result of it, its separation is not necessary. Only along with them some gangue particles will be there that we have to clean up or we have to wash us away, then wash it. Then as a result of it, we will be able to separate pure metals like gold, silver as well as platinum. But here one metal is there, that is copper. Copper never available in the free state. It is, that means it's it is available in the form of cuprous sulfide, we can say. Copper never available in the free state like gold, silver as well as platinum. This copper is available in the form of copper sulfide. That copper sulfide we can call as cuprous sulfide, Cu2S. Copper sulfide form copper is available in the reserves. It is not available freely in the nature. Now, when or how we can be able to separate copper from its sulfide compound? For that, we have to heat with oxygen. As a result of it, cuprous oxide as well as sulfur dioxide will form. Here cuprous sulfide, Cu2S, that means sulfur its valency 2, copper its valency 1. Copper has 2 valencies, 1 valency as well as 2 valency. Iron we had studied before, iron has 2 valency and 3 valency. 2 valency ferrous, 3 valency ferric. Here copper has 1 valency and 2 valency. 1 valency here, so we are calling it as cuprous. 2 valency copper will be there, then we are calling it as cupric. So here now cuprous sulfide reacts with the oxygen. That means when we heat it, as a result of it, which thing is producing? Cuprous oxide as well as sulfur dioxide is forming. So we have to heat it, then it is reacting with the oxygen. Now the formed cuprous oxide Cu2O reacts with cuprous sulfide. Here cuprous sulfide heated with oxygen, we can say, or with the help of oxygen. As and when we heat this, it reacts with oxygen automatically. As a result of it, cuprous oxide formed. This cuprous oxide again reacted with cuprous sulfide. As a result of it, we can say that copper separated as well as sulfur dioxide formation took place. So we can say that this cuprous oxide reacted with the cuprous sulfide. Here the separation of copper took place and sulfur dioxide also took place. So we can say that from these two reactants, copper as well as sulfur dioxide formed. Now here we have to balance both the equations. Here now Cu2, here also Cu2, here sulfur 1, here also sulfur 1, oxygen here 2, here 3 is there. So we can be able to increase this single is there, so that I am making now double. As a result of it, we can say that now copper, oxygen 2, sulfur, here also oxygen 2, 2 plus 2, 4 became, here only 2. So left hand side I am putting now 2, 2 2s are 4. Now here the number of copper 2, here the number of copper 4. So I am putting here now 2. As a result of it, sulfur number now 2, here sulfur 1 is there, so I am putting here now 2. As a result of it, here now oxygen 2 2s are 4, 4 plus 2 6 became, so here I am making now 3. Now let us see 2 Cu2, that means 4 Cu, here also 4 Cu, here sulfur 2, here also sulfur 2, oxygen now 3 2s are 6, here 2, 2 plus 4 oxygen, that is 6. Now let us see here. Here copper 2, again 2. So copper 4, I am making here 4. Not to put any number downside. What all number we want to add while balancing, that should be put left hand side of each and every formula. Here now copper 4. Oxygen here 1, here oxygen 2. So I am putting here now 2. So oxygen 2 became, at the same time copper here now 4, 4 plus 2 6. So I am making here now 6 copper. Now let us see sulfur how many. Sulfur here 1, here also 1. So equation balanced. Once again we will have a look. 2 Cu2, 2 Cu2. Sulfur here 2, sulfur here 2. Oxygen 6, here 2 2s are 4, 4 plus 2, 6 oxygen. Here 2 Cu2, 4, 4 plus 2, 6 copper, here also 6 copper. Oxygen here 2, here also oxygen 2. Sulfur here 1, here also 1. What is aquaregia? Aquaregia is a highly corrosive as well as a fuming liquid. It is a reagent. Its meaning, it is a reactant. Fuming liquid. Its meaning fume. Fumes are coming from that liquid. That means we can say that smoke is coming from that liquid. Corrosive means it is highly reactive liquid. Now this liquid's speciality, it can dissolve gold as well as platinum in that liquid. Now gold as well as platinum can dissolve in several liquids. This aquaregia is one among them. Now we have to study how we can be able to prepare aquaregia. We can freshly prepare aquaregia by mixing 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid. So here aquaregia we can be able to freshly prepare. Freshly means a newly prepare. How? 3 parts of concentrated hydrochloric acid we have to take it, and 1 part of concentrated nitric acid. Then we have to mix them well. Then it will become aquaregia. In that, gold as well as platinum can dissolve. These metals we can call as noble metals. Thank you.